Study Section 10, Hypergeometric Distribution. 1 week or 2 contact hours. Introduction. In study sections 9, we discuss the binomial distribution, where the sampling is with replacement and the probability of occurrence is thus constant from trial to trial. In these study sessions, we shall be considering the hypergeometric distribution, which involves sampling without replacement. Learning outcomes for study section 10. At the end of these study sessions, you should be able to state its probability density function, derive the mean and variance of the hypergeometric distribution, binomial distribution as an approximation to the hypergeometric distribution, state its probability density function. Consider a lot consisting of m plus n items, of which m of them are defective and the remaining n of them are non-defective. A sample of r items is drawn randomly without replacement. Let x denote the number of defective items that is observed in the sample. The random variable x is the hypergeometric random variable with parameters m plus n and m. Then, the number of ways of selecting x defective items from m defective items is mx. The number of ways of selecting r minus x non-defective items from n non-defective items is n combination r minus x. Therefore, total number of ways of selecting r items with x defective and r minus x non-defective items is m combination x in bracket n combination r minus x in bracket. Finally, the number of ways one can select r different items from a collection of m plus n different items is m plus n combination r. Thus, the probability of observing x defective items in a sample of r items, probability density function is for x is equal to 0, 1, 2, r x less than or equal to m, and r minus x less than or equal to n. Example 1. In a lottery, a player selects 6 different numbers from 1, 2 to 44 by buying a ticket for 1 naira. Later in the week, the winning numbers will be drawn randomly by a device. If the player matches all 6 winning numbers, then he or she will win the jackpot of the week. If the player matches 4 or 5 numbers, he or she will receive a lesser cash prize. If a player buys 1 ticket, what are the chances of matching A. all 6 numbers, B. 4 numbers? Solution. Let x denote the number of winning numbers in the ticket. If we regard winning numbers as defective, then x is a hypergeometric random variable with m plus n is equal to 44, m is equal to 6, and n is equal to 38. A. Probability of x is equal to 6 is equal to B. Probability of x is equal to 4 is equal to 0.0014938. Example 2. As part of a health survey, a researcher decides to investigate prevalence of cholera in 8 suburban areas out of a city's 28 suburban areas. If 6 of the suburban areas have a very high prevalence rate, what is the probability that none of them will be included in the researcher's sample? Solution. Recall that we have f of x is equal to has the PDF for hypergeometric distribution. Here, x is equal to 0, n is equal to 22, m plus n is equal to 28, and m is equal to 6. Then we have, complete this, mean and variance of hypergeometric distribution. Mean. If function of x is equal to let is equal to x minus 1, x is equal to x minus 1, x is equal to s plus 1. This implies is equal to Note, if the sampling was with replacement, R and P is equal to M over M plus N would be the appropriate binomial parameter, and its respective variance would be R M over M plus N into bracket 1 minus M over M plus N. The binomial variance is slightly greater than the hypergeometric variance because of the factor M plus N minus R over M plus N minus 1 in bracket in the hypergeometric variance. As M plus N becomes very large compared to R, the hypergeometric distribution tends to the binomial distribution. Binomial distribution as an approximation to the hypergeometric distribution. Suppose the PDF of a hypergeometric distribution is given by function of x is equal to, then we have the following theorem. Theorem such that let M n approaches infinity, and suppose that M over M plus N is equal to, then M combination x in bracket N combination R minus x in bracket over M plus N combination R in bracket approaches R combination x in bracket P raised to power x Q raised to power N minus x. X is equal to 0, 1, 2 to R. Proof. We have is equal to divide through by M plus N implies, since M over M plus N implies P, hence N over M plus N implies 1 minus P is equal to Q. Therefore, is equal to R combination X, P raised to power X, Q raised to power R minus X. This result implies that we can approximate the probabilities by setting P is equal to M over M plus N, provided M, N are large. This is true for all x is equal to 0, 1, 2 to R. If M, N are large, approximate the hypergeometric distribution by an appropriate binomial distribution. If the need arises, we may also go a step further in approximating the binomial distribution by the appropriate Poisson distribution. Summary of Study Section 10. In these study sessions, you have been able to 1. Describe an hypergeometric experiment given its probability function as 2. Show that the mean and variance of the hypergeometric distribution are and respectively. 3. Approximate the hypergeometric distribution using the binomial distribution. 4. Solve problems on hypergeometric distribution. This is the end of Study Section 10. Thanks for listening.